Welcome to InventorCAM Professor on our series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be showing you the use of 2.5D milling on both sides of this part as shown in our Getting Started manual. If we take a look at this part at our Coordinate System Manager, and I'll open it up for you, you'll see that we have the following. We have our first position, and we have our second position. In other words, we have two home positions for this particular part here. And we'll start off our operations in our first home position. Now, the first thing that I've done was a profile operation, which actually works on the step itself with an offset. Let's take a look at what I've done actually within the operation. If I were to open the operation, we'll see that my geometry, again using position 1, is actually just this line in itself. The tool that I will be using here will be a 10mm tool, and my levels, my profile depth, is up until that floor as shown over there. In my technology field, we've used a step down of every 4mm in the rough fashion, leaving a 0.5 millimeter offset on the wall. And we've also used a clear offset so that we have an offset of 30mm, so as the tool will start 30mm away from here back, and every single time it goes in, it'll step over 8mm. Now, another thing we've done here is also in our link area, we've actually approached using a tangent, so it'll actually step out, start from 15mm out in a tangent towards the line itself, and the same thing in our lead out. If we take a look at the simulation itself, we'll see that the tool goes down and over every single time until it finishes that step over there. In my next operation, I've decided to work around this area over here, this stub that's sticking out, and in the operation itself, we'll see that my geometry is the boundary as shown here on the top of the part. The tool, again, I'll be using the same tools as before, the 10mm end mill, and my levels again will be up until this floor itself. Now, in my technology area, I'll be doing a rough cut and stepping down again every 4mm, leaving a 0.5 millimeter material at the end. But I'll also be doing a finish cut. And my finish cut, I'll be going around it twice. Again, also stepping down every 4mm. In my link, in this particular case, I'll be approaching again in a tangent, but this time my arc will be used for my lead out. If I take a look at the simulation itself, we'll see that the tool goes around in a tangent fashion from here, and at this end over here, it goes out in an arc. Now, in my next operation, I've decided to work around this area here, covering this area of the step all the way down to here, through this side over here. So in my operation, my geometry in this particular case is this area as you see over here, as shown over here. The tool, again, I'll be using the 10mm tool, and my levels, this time my level is all the way down to that step itself. In my technology, I'll be using a rough cut going down every 2.7mm and with a 0.5 millimeter offset. And again, I'll be using a finish cut for this part. And in my links, in this particular case, I have approached with a 8mm tangent. And again, just to show you how the arc works, I've used a lead out with the arc. If I have to do a simulation, and this time, you know what, I'll use my 3D simulation, you'll see that the tool goes down in a tangent area around the corner, and then works out its way out using an arc. And it does this all the way down to the very bottom of the part itself. In the next operation, I've decided to machine around the whole part itself. So in my operation, my geometry in this particular case is the outside boundary of the part itself. The tool, again, I'll be using the same tool. And my levels, this time my upper level is up from here only, not from the 0, but from here, because everything up until this level has been machined already. And my profile depth will be the very bottom of the part. And I've added also a delta depth of a 0.5 millimeter to go a little bit past the part itself. In my technology, again, I'll be using a rough and a finish cut. And in my link, I'll be approaching with a tangent and have the same as for my lead out. Again, if I do my simulation, and again I'll use the option of 3D simulation, you'll see that the tool goes down, works its way around, and cleans up the entire part around. In my next operation, I like to mill out this pocket around here. So, in my operation itself, the geometry that I've chosen was this boundary over here, as shown over here. The tool, I'll be using the exact same tool I used last time. My levels, my upper level is actually this floor over here, as shown over here, this floor over here. And my lower level is actually the very bottom of that particular pocket up until this point over here. However, I've also given it a delta depth of a 0.5 millimeter to go a little further down past that point itself. In my technology area, I'll be using the contour strategy to clean out the pocket. And in my link area, I'll be approaching using a helical fashion, and my lead out will be in an arc of a 0.5 millimeter. If I take a look at the simulation itself, you'll note that the tool itself will go in a helical fashion and then clean out the pocket and then continue down until it finishes out the pocket, the entire pocket itself. Now, in my next operation, I like to clean off these areas over here, and again I'm using the pocket option. And if I open up my geometry, you'll note that my geometry is including this time the outside boundary of that pocket and also the inside boundary. I don't necessarily have to do it this way, but I just wanted to show you what happens if I choose this as an island and what happens in these areas. Again, my tool, this time I'll be using a 3 millimeter tool. My levels, my upper level, and then my pocket depth up until that floor itself. My technology, again, I'll be using the contour option to mill this out. If I do my simulation, you'll note that the tool itself, and this time I'll use my top view, showing you the tool itself also as well. You'll note that it works in this area and in this area, but did not go into this area and did not go over here, simply because the tool itself was not able to go in between this area. Now, in my next operation, I've just used this area just to clean out these corners over here, but I'd like to actually jump to the operation following. And the following operation, I'd actually like to work just along the walls itself, and there's no reason for me to really work in a pocket formation at this point anymore, so I'll simply use a simple profile operation. And the geometry is now just the outside boundary itself. My tool will be a 3 millimeter tool. My levels, my upper level, my profile depth up until the floor over there. And my technology, I'll be using a rough cut to cut that area out. But I'll be using a 0 millimeter offset in the part itself. So actually just getting like a regular finished cut. If I were to show you the simulation, you'll see that the tool works its way around just the edges of the part itself. Now, if I go into my next operation, I'll be doing a pocket operation inside here, but since I already milled out the inside, and we'll take a look at the pocket itself using the same geometry as I did before, I'll be using a smaller tool, a 4mm end mill, but in my technology area, I'll be using rest material, and in my rest material, I'll state, I just want you to work around the profile. In other words, I don't want you to clean the inside of this pocket here. I just want you to work within the profile itself. And wherever the previous tool, which was a 10mm tool, worked, wherever we had those kind of a corner, I want you to actually slow down until you pass that area and then continue working on in the regular feed. If we take a look at our simulation, you'll see again that the tool goes around exactly working as if it was a profile operation. Now, if I go into my next operation, I'd like to actually finish off these corners over here. So what I've done here is very simple. I've simply gone and used the profile operation, and in my geometry, I've simply chosen these borders as shown around over here. I've used a 4mm end mill, my upper level being this top surface over there, and my profile depth up until the floor over here. And in my technology, I've used the clear offset so that the tool can actually work from the outside in, because my tool is really not big enough to cover that entire area. My link area, again, using a tangent for approach and a tangent for lead out. And in my simulation, you'll note that the tool actually clears every single one of those areas around the part itself. And I can also show you this in my top view of my simulation. Now, for my last operation on this side, I'd like to simply work on the face of this part itself. If I were to go into my operation, I've done a face mill operation over here. If I go into edit, you'll see I'll be working actually on this area over here. My tool will be a 10mm tool. My levels, I'll leave it, my upper level and lower level, to 0. And my technology area, I'll be using the hatch form to do my cutting on it. If I take a look now at my simulation, you'll see that my tool will actually cover this entire area working back and forth. If I will take away the show tools option in my simulation, you'll see the actual tool path of the lines going back and forth on the part itself, covering the entire face. My next operation, I like to start working on my second side, my position 2. And the first operation I like to do is to do a face mill on this side over here. So I'll simply show you the operation. And over here I've also done working on position 2, having a face mill around the outside boundary of the part itself. My tool again being the 10mm end mill. And my levels, my upper level face depth, both at 0. And again working in the hatch fashion to cover this area as seen in the simulation itself over here. Now in my next operation, I want to mill out this pocket up until this step over here. So in my operation itself, I've chosen my geometry again in position 2 to be this shape over here, this entity, these entities over here, to go down up until that point over there. If we have my tool, I'll be using again a 10mm end mill, and my profile, my pocket depth will be up until the step as shown. My technology, I'll be using your contour option, leaving 0.2mm offset on the walls itself, and my link, I'll be using this time a linear ramping. And if I do my simulation, you'll note, and if I go down one step at a time, you'll see that the linear ramping is going in a zigzag fashion until it gets down, and then continues on until it gets to the bottom of that area itself. Now, my next pocket area would be going down over here, and basically the same as the previous operation, just my geometry was different to include just these areas around over here. Now, in my next operation, we're actually going to be working a profile around this area over here. And if I go into the operation itself, I'll be using my same geometry as I did in my pocket operation, profile 11, as shown over here. My tool, however, will be a smaller end mill. My levels will be, again, up until the step itself. In my technology, I'll be using your finish cut with a link in with a lead of arc 2 millimeters, and the same for my lead out. And again, if we look at our simulation, you'll note that the tool just simply goes around, lead in, lead out, using an arc fashion to do so. Now, my next operation will be very similar to the previous operation, except this time it'll work up until doing this area in the profile operation up until this step as shown over here also, covering this entire area. Now, my next operation will be a pocket. The pocket now has to cover this area over here, and it also has this island here to take care of. So what we've done over here, and if we take a look at the geometry itself that we've chosen, the geometry will be going around the part like this. Now, if I go into my tool, I'll be using a 4 millimeter end mill. My levels, my upper level will be this surface over here, and my pocket depth will be that surface over there. My technology, using a simple contour with a linear ramping in and a lead out of an arc. And if we take a look at our simulation, we'll see that the tool only works in that area as shown over here. The next operation, I'm just going to do a simple profile around here just to clear off this area around here. And if we take a look at the operation itself, you'll note my geometry is just this area around the little stub that's sticking out over there. And again, I'll be using the 4 millimeter end mill. My levels and my technology. In my link, I'll be going in a tangent fashion to cover that area shown over here. So it can go in actually from the outside over here, milling away this area which was not cleaned off yet. And the same thing with my lead out. If I do my simulation, you'll see that the tool goes exactly around the part itself. Now, to finish off this part, all I have left now are these drilling operations as shown over here. So my first drilling operation, I've actually chosen these 4 holes around the part itself. My tool will be a 1.8 millimeter 90 degree center drill. My levels will be upper and lower level both be 0 up until it reaches a depth of the diameter of 1.5, and a simple drilling operation G81. Now, in my next operation, I've used the same tool, but this time it's working on these holes shown over here. And my levels, this time my upper level is the surface over here. And again, I'll use my drill depth of 0, but this time only 1 millimeter of the diameter of the tool will reach that particular area over there. Now, in my next drill operation, I'm using again a center drill, but this time my geometry, using the same thing I've done before, will be on these holes over here. Now, in my next operation over here, I'm actually going to drill out these holes on top, and I'll be using a 2.3 millimeter drill. My levels, this time being my upper level as shown here, and my lower level actually being the very bottom of the part itself, to the very bottom as shown over here. And I've added also a delta depth of to go down another millimeter, and I want the full diameter to get to that depth. And if I go down to my next two operations, I've done the same thing with the different size drills, what's needed for those holes, using the same type of technology that I use for these holes over here. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.